Hi, welcome to Wise Guys. This video is on ratio and proportion, direct proportion, and I'm going to walk through a couple of questions. Alright, so the first question here. City A is 768 kilometers from City B. And on a map, this distance is 8 centimeters. So here's City A. Here's City B. In reality, the distance is 768 kilometers. On a map, that looks like 8 centimeters. Now the question is, what is the distance? So we're trying to find distance between two locations that are 15 centimeters apart on a map. So these two new locations, which we don't know, we'll call them C and D. So this distance here, the real distance, is the thing we're looking for. And on a map, it's shown as 15 centimeters. So just by looking at this, we can see how to set up the ratio and proportion. The 768 kilometers is the 8 centimeters on the map. And notice that we can even just say we're setting it up this way. The real distance, okay, and the map distance. So real over map. So 768 kilometers over 8 centimeters equals the unknown kilometers over the 15 centimeters. Now again, we're trying to solve for x. So we multiply here by the 15 centimeters, multiply this side by 15 centimeters. 15 centimeters divided by 15 centimeters is 1. So then we have our unknown equal to 768 kilometers times 15 centimeters divided by 8 centimeters. Notice that our centimeters cancel and we're left with the units of kilometers. So now we take 768, multiply it by the 15, divide it by the 8. And we get 1440. So that distance is 1440 and our units are kilometers. So the distance between these two cities that were shown as 15 centimeters on the map is 1440 kilometers. Now let's look at the next question. Here we have a man who's standing near a tree. If the 36-foot tree casts a shadow which is 42 feet long, how tall is the man if he casts a 7-foot shadow? Okay, so sometimes it helps to draw a picture. So here's a tree. All right, there's our tree. And we know that the tree is 36 feet. And there's the ground. So the shadow of the tree from here to here is what? 42 feet. So there's our 42 feet. And here's a man standing right here. He's a pretty tall man. Okay. And how tall is he? That's what we're trying to find out. So we're trying to find out what this distance is here. That's the question mark. How tall is he? And let's get a different color pen. Everything looks really dark here. No. This distance here So the distance for the shadow of the man is 7 feet. And we want to know his height. So then we can say height over shadow. So we can set this up as height divided by shadow. The height of the tree is 36 feet. The shadow of the tree is 42 feet. The height of the man is the unknown. The shadow of the man is 7 feet. Notice as well that I try to set it up so the unknown is in the numerator. We could set it up so both of these were flipped, but it just makes the math a little bit more work. So you have x on top. We only have to do basically one step. We're trying to solve for x, so here we multiply by our 7 feet. We multiply on this side by the 7 feet. These two become 1, and we're left with x equals 36 feet times 7 feet divided by 42 feet. These feet cancel. And now, well, actually we can do this piece. 7 and 42, they're both divisible by 7. So I can divide this by 7 and get a 1. I can divide this by 7 and get a 6. 36 divided by 6 is 6. So x equals 6 feet. And 6 feet is the height of the man. So that's the height. Okay. All right. Now where are those glasses gone? Here they are. That video was brought to you by Wise Guys. I hope you have a good day. Take care.